Hello, and in this lecture we are going to study what is greedy algorithm and some of its application. So as greedy algorithm is mentioned on the Coleman book, a greedy algorithm always makes the choice that looks best at the moment, that is, it makes a locally optimal choice in the hope that this choice will lead to a globally optimal solution. Now what does it means? Suppose this is a graph and we have to find out the minima of this graph. So obviously the whole graph is before us, so we could easily say that this point is the global minimum. Now if our starting point is this, and we suppose you are a very tiny creature and you are at a particular time, you are here and your task is to find out the minima of this curve. Maybe in desert you have to find out the deepest point. So what could you do? One approach is you just traverse the whole desert and then find out this is the minimum point, this is the deepest point or minimum. But that is not practically possible that you could visit the whole desert. Now what could you do? Just find out what the gradient descent method said, that wherever you are standing, just look what is where the slope goes. If it is downward, so move that in that direction where the slope's going down. So you let's say you take a step here, you apply same approach, you step here, you will be landed here, then here, and if you are here, once you are here at this point, now the slope again rises. So what could you conclude? This is a minimum point. I am talking about gradient descent method, but this is you could apply for finding the deepest metal in the deserts. So now you are stuck in local minima. Why you stuck in local minima? Because whatever your approach is, that would give you in this position that you can't go beyond this point. So greedy algorithm is work something like this, that you have to, there is a, let's say this is the solution domain, and let's say your exact solution is here. So if you are solving some problem through greedy algorithm, it's not necessary that you would approach here. You could reach at this point, as here the actual solution was here, but you were stuck right here. So greedy algorithm could not guarantee that it would give you a solution in general, but obviously it could, in some cases it might give you the guarantee. So in the cases where greedy algorithm could give you guarantee to give the solution, only in that scenario you could use greedy algorithm. And where the greedy algorithm is not could give you the guarantee to reach the solution, you should not use that particular algorithm in those scenarios. So greedy algorithm might give you here solution like this, somewhere close to your actual solution, but may not be actual solution in some cases. Now where the greedy algorithm you are going to use? So, optimization problem. So if there is some optimization problem, you could use this greedy algorithm, provided that greedy algorithm in that particular scenario will give you guarantee to get the solution. Now what is optimization problem? For example, if there is a problem statement and suppose there are multiple solutions, and what the most suitable solution is, like suppose if I would say what is the, like in this particular example, if I would say what is the minimum value, so this minimum is the optimality of things. There are multiple values multiple minimum value, like this is local minima, this is local minima here, but this is also global minima for this piece of line, this piece of curve. So there are multiple solution exist, but this is the actual solution, the optimal solution. So as a thumb rule, or you could say where you find minimum or maximum in your problem statement, you could say that problem is going to be optimality problem, optimal problem. You are going to find the optimal solution for that particular problem. So here the minimum value, so might be question could be like find out the maximum value. Well, in that case these would be the possible solutions, and you have to maximize the value. So this would give you actual solution because this is the highest value. So that would be the solution if in case of maximum. In case of minimum, this is the solution. So greedy algorithm is you can apply where the you would have to find the optimal solution. 1, 2, guarantee algorithm could not give you guarantee to find out solution. So you have you could only use greedy algorithm where you could prove that yes, greedy algorithm could give you the solution with guarantee. So in next slide, these are the things which give you a guarantee. If you could prove these steps, then that would give you guarantee that yes, greedy algorithm could give you the solution with guarantee. I mean, there is no way that if these conditions are satisfied, then it can't be happen that greedy algorithm could not provide you the solution. So this is what I said in previous slide. The greedy algorithm do not always yield optimal solution, but for many problem they do. So the category of problem where this greedy algorithm works, we apply only on those problems. So what are those steps? So determining the optimal substructure of the problem. Now what does the mean of substructure? You will read it in detail when you go through with dynamic programming, but substructure means if let's say if you would like to find a solution of particular problem, so what could you do? If you could reduce, you could divide your big problem into smaller one, and the optimal solution of the smaller problem or component problem would directly contribute into the optimal solution of the global problem or the whole problem. And it happens for each and every case, each and every substructure. Then you would say that this problem follows the optimal substructure characteristics. So if it is not followed by any problem, so you could not apply greedy algorithm. One, the problem should be optimization problem, and if it is optimization problem, it should also follow the optimal substructure characteristic. If it is not using that problem don't have this type of characteristic, you can't apply greedy algorithm at all. But this characteristic is also used in dynamic programming. So this point, if this point satisfy, you could go with dynamic programming. Of course there are some more characteristic with dynamic programming as well, and you could also go with greedy algorithm. Now when to go for dynamic programming and when to go for greedy algorithm, so that there are remaining characteristic. On the basis of that, you could decide for which way you should go. Obviously in case of dynamic and greedy algorithm, if something could be solved by greedy algorithm, you should not opt for dynamic programming, because the dynamic programming are computationally very costly. So if a problem could be solved by greedy algorithm with guarantee, then definitely you would go for greedy algorithm only and not dynamic programming. You should go only in that case for dynamic programming when greedy algorithm could not work, because it comparatively it is much computationally economical than the dynamic programming in general. So if it is so, develop a recursive solution of that problem, optimization problem, and prove these things that at every step of recursion you could there must exist a optimal choices there. So whenever you are designing some greedy algorithm, you must have to apply some heuristic. Only that, due to that heuristic, the computational cost get reduced in greedy algorithm in comparison to dynamic approach or dynamic programming. In dynamic programming, you are going to going to calculate all the possible combination, and then you find out the which cost is maximum or minimum depending on the problem. So that is that heuristic. If you apply that heuristic intelligently, the cost of the algorithm, which in the case of dynamic programming is quite high, would become much low. So that is the human intervention is required for using the heuristics of that thing, and that heuristic should should give you guarantee that for each and every step of recursion you must have optimal a greedy choice of that problem. Now if you would go through all these steps, and if each and every steps are completed, you are able to complete, well, in that case you could say that yes, greedy algorithm will give you the solution for guarantee. So if these characteristics are going to fulfill, you are able to fulfill, then only then you could apply the greedy algorithm. So there is a problem named knapsack problem. So let's see what this problem is, and then we try to relate it with the greedy approach. So knapsack, the word meaning of knapsack, you could say it is a bag or something. So there is a bag and there are some items are available. Now your objective is, one thing is you have a bag with some limited capacity in term, it could be in terms of weight or maybe volume could be, but in majority of the cases the weight is the capacity of the bag. So you have a knapsack or bag of some given capacity. In this particular example it is 15 kg capacity, so this bag could not bear load more than 50 kg. Now kg and rupees, it is currency, it is in dollar, but it could be anything, unit could be anything. So the capacity of your bag is 15, and there are some items having some weight and the cost of that thing. In some numerical it is also given as the profit of that item. So this is the weight of this particular, let's say I'm saying that the green item. So green item having weight 12, having cost 4, cost or profit with 4. Likewise this gray item having weight 1 kg with 2 unit price, and so on. Now if the question is, if I would say, how could you pick those elements such that once you fill this bag with these items, the cost of your bag would be maximum. No, maximum. So once I am saying maximum, that means the chances are quite high that it is the optimization problem. Now in case of optimization problem, if you would in some books it is also written that a thief is there and he has some bag and these are the items. So thief could not bring all the items because due to the limitation of the bag capacity. So the thief have to decide which item he should pick inside the bag. Now there are two versions of this problem. So this is the general statement of the knapsack problem. Now there are two versions of that thing, 0-1 knapsack problem and fractional knapsack problem. In 0-1 knapsack problem version, it is assumed that each and every item is as it is you have to pick. Means if thief has decided that this item should be picked, then there should be no fraction. The thief could not make it half or fraction of that item. The thief have to pick the whole item as a whole. So this 0-1 represent either you take this item or don't take this item. So if you are taking this item, that is 1, and if you are not taking this item, that is 0. So either you have to pick this whole item, this item as a whole, or you don't pick. The same with the all other remaining items. And in fractional knapsack problem, the assumption with these items are you could take the fraction of this item. So for the sake of simplicity, you could also consider it as like these items are available in the powder form. So you could take half of this item, 1/4 of this item, 1/8 of this item, and so on. So you could take any fraction of this item. So if you have a choice, the in the thief example, if the thief have a choice to pick the item in fraction, then well, in that case, that knapsack problem is known as fractional knapsack problem. If thief don't have choice to take the item in fraction, in that case that would be the 0-1 knapsack problem. Now if you for 0-1 knapsack problem, if you pick that the greedy approach, so what greedy approach says, whatever seems to be beneficial for the time being, just pick that item. So if you follow this approach, so this is just heuristic, that whatever's the cost of whatever thing is high, just pick that one. This could be one choice. So cost of item here is the most costly item is $10. So $10 with 4 kg. If I pick this item, my bag after picking this item, my bag capacity would become 11 kg, because 4 kg has been reduced from here. So 10. After picking this item, the cost of bag would be 10 and the weight is remaining with 11. Now the next most costly item would be this 4. Now but we can't pick this one because the remaining capacity of bag is 11, since it was originally 15, but once I pick this one, the remaining capacity of bag is 14 kg now. So I can't pick this one. So next the next costly item is 2 kg and 2 kg. So pick either of the thing. If we are focusing only on the weight, or only on the cost, so we could pick either of the items. So if suppose I could pick this one, so the bag capacity would be 10 plus 2, that is 12, and after picking this item, the bag capacity will remain 9. 11 minus 2, 9. So likewise, if we go with this approach, what do you think? Could we get the maximum amount in our bag in terms of these dollars? No, that would not be the case for in general. Now if suppose if I focus only on weight, so pick the maximum weight or pick the minimum weight, so that overall cost of once my bag is filled as much as possible, well, in that case the cost of my bag due to these items would be maximum. No, well, it could not be the case in both of the scenario. It can't give you guarantee that the cost of the bag would be maximum. So heuristic is on one item could not give you solution with guarantee. So you can't use greedy algorithm, greedy approach on the 0-1 knapsack problem. So for that we would use dynamic programming, which we will see in future. Now in fractional problem, these items are available in the fractional form. You could consider it as, you could take it these items are available in powder form. So this is 12 kg in total, so you could take 6 kg, 3 kg, 1 kg, 0.5 kg and so on. You could take any fraction of this item. So if 0-1 knapsack problem is not applicable, you could not apply the greedy algorithm of this 0-1 knapsack problem. Now for fractional problem, let's see. If we focus only one thing on either price or the weight, you won't get the correct solution for guarantee. Maybe in some cases it work, but in general for all the cases it won't work. So what could we do? We simply take which one is the most precious item. Like maybe you could say this, a gold is there, some diamond is there, some cotton is there, and something is there. So let's say 10 kg of cotton and 1 gram of gold. So in terms of weight there is a huge difference, but in terms of cost, the 1 gram gold is quite costly than 10 kg of cotton. So instead of taking one factor, either weight or cost, just take them jointly, so that the more clear picture would be available to us. So take the unit price of each and every item and order them, sort them in terms of their unit price. So take the decreasing order. So the most costly item would pick first, and then second costly item, and then third costly item, and so on. So let's take an example here. Suppose these are the things, these are the item names: item A, item B, item C, and D. If there are 4 items labeled as A, B, C, D. Now the profit or cost is 280 for item A, 100 for item B, and so on. And the weight of item A is 40. Now it could be gram, kilogram, metric ton, anything. So there is no unit is written here. So it is dollar, rupees, or what, dinar, whatever it is. So this is the price of that item, and this is the weight of this item. Now we are considering each unit is homogeneous. Like if it is rupees, all of them are in rupees. If it is in kg, then all of them are in kg. So, and now the bag capacity is 60 kg. So you have to pick these items in such a way that 60 unit bag capacity could contain the maximum cost of item, the item which cost is maximum. Now how could you do that? For that, make the unit price of each and every item. So how could you do that? Simply divide the price divided by weight. So the cost of this one is 280 divided by 40 would give you the unit price of this item. So unit price of this item would be 7. The item A, the unit price would be 7. Likewise, item B, unit price of that would be 10, because the weight of 10 kg having cost 100, let's say, rupees. So for 10 kg 100 rupees, for 1 kg it's 10 rupees. So simply 100 divided by 10, so 10, 120 divided by 26, and so on. So this is the unit price. Now which one is the most costly? Obviously B is the most costly item, and B is the most costly item. Next costly item is A. Third costly item is this one, and fourth costly item is this one. So just simply sort them in order of their unit price, unit weight price. So this is the thing. Now this is the most costly item, second most costly item, third, and this is the cheapest item we have. Now you have a bag capacity 60 kg. So now we start to fill our bag. So if the 60 kg bag is there, 60 bag capacity, the bag capacity is 60 kg, it's not the weight of that bag is 60 kg. So capacity is 60 kg. Now we just put the most costly item B. The weight of B is 10 kg. Could we put this item into our bag? Yes, of course, because we have a 60 kg capacity and the item B weight is only 10 kg. So we could easily put this item into our bag. So let's say we just put this item into our bag B with capacity 10 kg. Now once we put this item into our bag, now our new capacity would become 60 minus 10, 50. So we have left with bag capacity 50 once we put this item into our bag. Now the second most costly item is A. The weight of this bag capacity is, the weight of this item is 40 kg. Could we put this item? Yes, of course we could put this item, because the bag capacity is 50 and this item having a weight 40 kg, so we could easily put that item. So just put that item into our bag. So A with weight 40, and now our bag capacity would remaining 50 minus 40, 10. Oh sorry, 10. The earlier the bag capacity was 50 and we put the weight 40. So 50 minus 40, the remaining bag capacity is 10. Now the next costly item is C. Now weight of C is 20, but here the bag capacity is 10 kg only. I am taking the unit kg and rupees, but for the sake of simplicity only, there could be anything in dollar or something, anything. So the third item is C, which we have to pick, but the weight of this item is 20, while our bag capacity is 10 kg remaining. But since it is a fractional knapsack problem, we could put the fraction of this item, so we can't put C as a whole, but since it is a fractional knapsack problem, we could take the fraction of this item. So instead of taking 20 kg, we just pick 10 kg. 10, why? Because we have left with 10 kg space or capacity, so we put item C with 10 kg only, because the availability is 10 kg. Now the bag capacity remaining to 0 turns into the 0. So now bag is full, we can't take any more item. Now what is the bag capacity, the cost of this bag? Since the B, we put item B as a whole, so price of item B is 100. So this just the cost of this item is 100. And then we put item A as a whole, so cost of this item is as a whole, so 280. And then we put item C as a half. The cost of C is 120, but weight of C is 20 kg. So for 20 kg the cost is 120, but inside our bag we put just half of that C, item C, so cost will also we get half, so the cost would be 6C for item C. So the total cost of our bag would become 440. So 440 rupees or dollar, whatever it is. So the cost of this bag would be 440. And now you can't pick any configuration of these items, so that the cost of this bag would get maximum than this 441. So that is the knapsack problem, and it is that is how you could solve on your a fraction of knapsack problem, and this would give you the answer for guarantee. It can't happen that you are solving fraction knapsack problem with greedy algorithm and it would give you incorrect answer in any case. So with guarantee, the greedy approach will give you the correct answer. So in case of fraction knapsack problem, you could simply apply greedy algorithm. So that is all about greedy algorithm. Thank you.